Hello guys. In this video, I'm gonna give you a ultimate introduction to data structure and algorithms in a very simple English. So if you're a student or a working professional or just want to know the basics of data structure and algorithms, then this is the video for you. Let's look at the agenda now. First, we'll see what is data structure and algorithms. We'll try to understand why it is so important. We'll solve a puzzle and we'll enhance a feature and we'll just look around to see what are the data structure and algorithms in our real world, and finally we'll see some of the common DS and algos. If this is exciting you or if this is what you wanted to see, then let's dive into the video now. This is what a legend said about the data structure and algorithms. If a software is a world, data structure and algorithms are the principles that enable it to run efficiently, and that legend is myself. You will understand the meaning of this quotation, or it will start making sense once you complete the entire video. Okay okay what is data structure and algorithm? According to me, in a very simple terms, the way you store the data is data structure, and the way you read the data is algorithm. In other words, the series of steps you perform to complete a task is an algorithm. Let's look at an example. Okay, what do we have here? Books. And these books are stored in shelf based on their category. And when we want to find a book, first we will find the shelf, and then we individually look at the each book to find our desired book. So what is the data structure here? Basically our shelves, and then storing them according to their category. And what is the algorithm here? First finding out the shelf and then individually looking at each of the book. Okay, let's look at another example. Let's say we wanted to save a cricket score data. How we can save it? Maybe let's take an Excel and then create this format. Here each row will become a over, and then columns will become individual balls data within each over. Okay, so if you want to find a score of a particular over and particular ball, simply we can go to that particular row and then pick the particular column. And the same can be represented in the computer world in this manner. And this is nothing but arrays, if you are already familiar. So here also we can do the same thing. Here also first find out your row, that is our over here, and then go to the particular column based on the ball you want to see the score. Okay, why the data structure and algorithms are important, right? Interviews. Yes, if you are from the computer background, you should expect that they will ask the questions about the data structure and algorithms. Is it just for the interview? No, it's more. But we'll come back to this slide after covering the other topics. Okay, ignore about the data structure and algorithms, all that aside, and then let's solve this puzzle. Okay, imagine there is an area. In that area, we have a lot of buildings, and each building has a number associated with it. And there is a thief entered this area, and he started stealing the money. So every second passes, he will steal one gold coin. And now you are a detective, and you have received an information that a thief is entered this area, and you also got an information that he is residing in a particular building number. But you are new to this area. So how you gonna catch the thief here? So you're gonna look at each building number and see if the building number is the same as what you have received. Um, so you individually look at each building number. If it is the number that thief is there, then you will find the thief. You will catch the thief. So you will look at each building and find him. This is fine. We are able to do it. But what if this area is big and it contains 100 into 100 rows and 10 columns in each row? So it will be like 1,000 buildings. So by the time you find the thief, he will steal all the money. But we are not just a normal person, we are a detective. So we have to think like a detective. So wear your detective caps and let's try to catch this thief efficiently. Since we are a detective, let's try to find some observations within the given problem. If you closely observe, all the buildings that are in vertical order have an increasing building sequence number. Same stays true for the horizontal line as well. Buildings are sequentially in increasing order. We'll remember this fact and try to use this while finding the thief. So let's start at the building number 23, and if the current building number is 23 and the target building number is 27, then we know that the buildings are in increasing order, arranged in increasing order. So 27 has to be coming after this 23. So there is a chance that the building that we are looking for might exist in the same row. So we look for one more building, I mean the next building. So 25, okay, 27 is still greater than 25, so still there is a chance that the building exists in the same line. But when we see 32, there is no way that the building number 27 can exist after 32, because the building numbers are arranged in a sequential order. So instead of continuing on that line, we go one level up. We will ignore about this row, we'll continue with the previous row. Now we are at the building number 24. So now 27 is still greater than 24. So there is a chance that the 27 can exist in this row now. So visit the next building now, 26. 27 is still greater than 26, so visit the next building, 30. As soon as you visit the 30, you know that the fact that 27 can't exist after 30. So again go one level up. Here we are in 22. So again we are looking for a 27 which is greater than 22. So visit the next building. Here we go. We found him. Gotcha. So this is the optimized way. If you just observe, every time we are hitting a condition, we have started to ignore the entire remaining row. That way we don't need to check every row completely. If you imagine this as the horizontal buildings as the columns and the vertical ones as the rows, in the worst case, how many buildings we will visit? It will be row plus column. For example, let's say the thief is at the building number 15. We'll start at 23. We know 15 is less than 23, so we can ignore the last row. We'll jump to the 21st. Again 15 is lesser than 21st, we'll go to the 18, we'll go to the 6. As soon as we hit the 6, 15 is greater than 6, right? So we'll start visiting the 7th one, and then the 11th building, and then the building number 13, and then we finally reach 15. So in the worst case, we need to visit row plus column buildings. Okay. And by the way, this is the one of the common interview problems asked in the coding interview questions. This is the search in a sorted matrix. All right, let's enhance a feature. Imagine we are building this feature called movie name search. Basically, we have a database with a lot of movie names, and then we want to create a search feature. Basically, what user will do, just like Amazon Prime or Netflix, user can enter a few letters, and based on the letters, we have to return the movies. Our brute force or the basic approach that I am planning as of now is read each record from the DB, and if the prefix matches with the entered string by the user, then return the result. Simple, right? Okay. Imagine each comparison takes 1 second. I mean the comparison to do the comparison for each of the movie in the database. And say we have 1 lakh movie records. By the time we return the result, user will be dead. He will be dead by waiting. So we have to come up with some optimization. We can't let the users wait for this long, and we can't even enable our servers to wait this long. Let's try a different solution. Yeah, this is not a typo. This is a data structure called try, mainly used for the prefix data search. So how this data structure is formed is we're gonna have a root node, and this root node we're gonna have a mapping for letters from A to Z. So in this root node we use something called hash map or hash table, so that the searching of the letter from this in this root node will be faster. Okay. And let's say we wanted to store the Dune movie. How we gonna store it? At the root level, we're gonna just have one letter stored. Let's say in this case Dune, right? So D is stored, and after the D again we're gonna have a hash map, and we're gonna store the next letter. That way, uh, the names are stored in a prefix manner. Got it? I think I'll give you one more example, then you'll start understanding it. Let's say we have a movie called Donkey. So instead of creating the new word itself, we already have a prefix for the first three letters. So this new word will get added after the n. So now n will have a mapping of two variables, two letters. One is e, one is k, and after k, k will have one letter. And the star we just use just to know that it's the end of the word. Okay. And let's say now we want to store a movie called Dunkirk. This is how we're gonna store it. Cool. Okay. Then we want to store another movie, Leo. This movie is starting with the letter L, so it will fall under the letter called L. And Saho and Solar will fall under yes. So hope you understand about the trie structure. This basically nothing but in each node we're gonna have a hash map mechanism, and then each node will have just only one letter, and from that letter it will have a mapping of the other letters which can exist in the movie name, which will exist in the movie. For example, if user is searching for Salar, right? Or if user is just typed SAL. So what we will do, first we gonna directly go for the S record. So as soon as we go for the S record, we already ignore the other 25 alphabets. Imagine like you are looking at a 1 lakh records, already you have avoided 90% of your search. I mean 90% of the movies that you don't need to look up. And then you go to the, since you S is matched, you start checking the next letter, that is A. Okay. And what is the next letter? L. So from this letter onwards, whichever the letters you have, that you create as a word and then return to the user. Okay. Let's look at another example. Let's say user has entered DUN. So we know where is D, and after D U and then N. After N we can see we have three movie names. One is Dune, one is Donkey, one is Dunkirk. So we written all these three movies. Okay. So here we still have 1 lakh records, but each comparison of the letter took only constant time. So now we can return the result instantly, and then user will be happy. Okay. Time and space complexity is about telling how much time and memory your program will occupy to complete your task. Okay. Let's look at a scenario. Imagine there is a train and you have two points, point A and point B, and the distance between these 2 points is 10 kilometers. And now your train completed your journey in 20 minutes. Okay. If the distance is 50 kilometers, how long the train will take to complete it? 100 minutes. And if the distance is 100 kilometer, 200 minutes. Um, how are we sure about this? Because we did the basic math. What is the math behind it? So first we found out, taken out the fact that a 10 kilometer is 20 minutes. Then we found out 1 kilometer is 2 minutes. Okay. And we came up with a formula. Formula is number of kilometers into 2. So if it is 50 kilometers, 50 into 200. If it is 100 kilometers, 100 into 2, 200 minutes. If you see this formula, this stays true for any input size. In the time and space complexity also, we're gonna do the same thing. We have to come up with a formula. That formula should stay true for the any given input size. If you look at our old example, right, where we have a buildings and we assume these are the row and these are the columns. In our old approach, without optimization, how many buildings we have to look? We have to look each and every building. So it will become R into C. So that is the time complexity here, because we are visiting every building. So even if the row size changes or column size changes, this formula will stay true. And in our optimized approach, how much it is? It will be R plus C. In order for you to just understand how optimized this solution is, I'm going to give you some numbers. So just imagine if there are 100 rows and 100 columns. With the old approach it will be a 10,000. With the new approach it will be a 200. You see the difference? Okay. And we usually represent the time complexity and space complexity in the data structure and algorithms part in a big O notations. Let's look at the example. Imagine you are searching for a number. What you will do, you have an array and you have a list. You have to look each and every number to find out whether your number is there or not, because there is a chance that your number exists in the last, so you have to scan through all of the numbers. So what is the time complexity here? Order of n. What is n here? Input size. So if the given input size is 100, then it will become order of 100. So that's why we represented it as a n, so that can be represented for the any given input. And just imagine if you are sorting the number in a basic sorting function. What we will do, at each number we're gonna scan through the entire list again, so it will become n into n, so n square. For example, if the given input size is 5, it will be a 25, and if it is 10 it will be 100. Now let's look at the space complexity. Just like time complexity, we also should say how much extra memory our program will take to complete. Okay, in this case the space complexity is n into l. What is n here? Number of words. What is l here? The largest number of characters in a bigger word, or the word with the max letters. Okay, why only the max letters? Because we wanted, whenever we are calculating this space and time complexity, right, we want to give the upper bound. That's why we are assuming all words that are given have the maximum letters in it. Okay, now this is the fun part. So we think data structure and algorithms are only in the computer, but they actually exist in our real world too. So let's look at some of them. Stack. Stack is last in first out. You can see this person is taking the last plate which is kept on top of the existing plates. So basically the last in and the first out. Where this is used in the computer world? In the control Z operation. So imagine you are in a paint application and you have added a couple of strokes. Now when you do control Z, the last stroke will be removed, and if you do control Z again, the last stroke which is previous to that stroke will be removed. Okay. And FIFO, first in first out. Imagine you are in a car race track, so the first car which is in the track, that will be gone out first. Where this will be used in the real world, sorry, in the computer world. If you are listening to the music, there is an option called add to the queue, so you will the music app will play one song after the other song. And imagine you are having a printer and you pushed a couple of jobs, so it will start completing job one after the other based on the time we submitted it. Okay. 2D array. If you ever played a chess, you can closely observe the grids can be represented as a 2D array. And where we use in the computer world, images. Here we can have each cell represented a color value between 0 to 255, and then the entire 2D array can represent an image. Recursion. Recursion is basically calling yourself within the same call. I know it might sound little confusing for you, but just imagine you are trying to solve a problem. For that, again, you are using the same function. We usually use in the tree or graphs while doing the traversals. And one of the common problems that solved using recursion is the towers of Hanai, where at every step we will imagine solving the full problem and then finally solve the full problem. Linked list. Here basically we have some nodes, and each node will have a connection to its next node. Okay. Where we used in the computer world, in the if you ever used the browser and visited a couple of sites, you have a left arrow and right arrow buttons. So this will be used to traverse between these sites one site at a time. The implementation behind this can be a linked list or maybe a doubly linked list. And if you ever played a video with the video players, there is an option for next and previous, so that also can be implemented with the linked list. And we will see some of the commonly used data structure and algorithms in the computer world applications. In Instagram, if we just open the following section, the accounts will be listed in a container. So this can be created with an array. And if you go to the posts are ordered based on the date. The post with the recent date will be showed up in the first. This is nothing but the sorting. And graph and recursions in the Facebook and the LinkedIn, we have this mutual connection with the graphs, right? We will create nodes and we'll find out the distance between the persons, and then based on the connection levels, we can understand if there is a mutual connection or not. Okay, we'll try to understand why it's important now, because we have a more context now. As we discussed previously, yes, interviews, if you are from a computer science background, you can definitely expect them to ask a few questions about this. And speed and smooth, since we're gonna come up with the optimized or efficient algorithm and data structures, so we're gonna complete our task faster and smoother, scalable. Our optimized solution stays true for the any input size, no matter how large it is. Resource consumption, since we're gonna complete in less time and less memory, so we're gonna consume less resources in the CPU, memory, or whatever the services we are using. And then cross domain, this data structure is not restricted to any one programming language. So if you learn it once, you can implement or use it in any other programming languages. And also you can be this can be implemented in the real world as well. And the cost, since we are completing the task faster, smoother, and then we are using the less resources, obviously it's going to benefit us in reducing the cost. Okay, some of the common data structures. Array is basically elements which are allocated in the continuous memory locations, and you can access them using their index values. Linked list are nothing but the objects, and each object will have the pointer to the next node or next object. Stack is basically when you push the items and pull the last item that you pushed recently, last in first out. And queue is again you push the items to a queue, and then you return the item that is first inserted, first in first out. Hash table or hash map is basically using the hashing technique, the keys will be figured out and the data will be stored, and the searching will be first in the hash table, because since the data is hashed, whenever you're looking for a value, again we're gonna do a hash technique and then find out the index, and we can simply know whether that value exists or not. And tree basically we have a parent and children, each parent can have sub children, and then the children can have again grandchildren, and we have the leaf nodes here. Graph basically we have different nodes, and it has a connection between them, and then it has a different edges and different directions to navigate through the graph. And try, we have already seen this is mainly used for the prefix searching. Okay, let's talk about some of the common algorithms. One is sorting, when you want to keep the data in a particular sorting manner, either ascending, descending, or based on some other factors. Searching, you have some items within that you wanted to search some items, so you can use a technique like binary search or different techniques to search your items faster. String algorithm, so within a string there is an algorithm called KMP and other algorithms to perform the operations related to string. Dynamic programming is where basically you start storing the smaller results and then use that to find out the final result. Tree and graph traversal, basically here we use breadth first search or depth first search to navigate through all nodes. Okay okay let's take a summary. We have seen what is in data structure and algorithm. We understood why it is so important. We have solved one puzzle and then understood what is the underlying data structure and algorithm there, and we have enhanced a feature using a try, and we have observed what are the some of the data structure and algorithms in our exist in our real world, and we have seen some of the commonly used data structure and algorithms. Okay, I think we've reached the end of the video, and if you have any questions and comments, you can add it in the comments, and that's it. Thank you. And I'm not asking you to subscribe to this channel because I'm not sure how frequently I'm gonna post the content here. But if you like this video and if you think it will be helpful for others, just leave a like and a comment and share it if possible. That's it. Thank you.